All right, guys, welcome to our review test study guide here. I'll go through the even problems. Let's begin here, number 2. All right, so now this is a what we call a multi-step equation. The goal is we want to solve for the variable. So typically, if possible, so I'll put a question mark after it, but if possible, distribute. So I do have distribution here. So anytime you have parentheses with a number in the front, you're going to multiply the number in front times the numbers on the inside. And after that, you can get rid of the parentheses. Sometimes you'll have to distribute twice, sometimes only once. It just depends on how many sets there are. Next, we're going to add or subtract the smaller variable on both sides. Okay, so I've got 40 in, and 5 in here. 5 in is the smaller one, so I'm going to add or subtract that. Now, how do you know which one to do? Well, you do the opposite of what it says here. So since that's plus, I'm going to be subtracting that smaller variable on both sides, making sure that you line up the like terms as you do. On this side, they should go away so that variable's not there anymore. Okay, the next thing you're going to do is either add or subtract the constant. That means the number without a variable. So in this case, the 24, I want to add or subtract that to get it out of there. I want to start getting the n by itself, so I want to move numbers away from it. The first number we get rid of is the constant number, the number without a variable. And so to get rid of that 24, that constant value there, I'm going to do the opposite of what it says. Since it's a plus 24, I'm going to do minus 24, and you do that on both sides. So I guess I should put on both sides. All right, so we have 35n equals, that's gone now, negative 35. And then after that, you're either going to multiply or divide the multiple. What do I mean by the multiple? That's the number in front of the letter that is multiplying it. So the number in front of the n here is 35. So I'm going to do the opposite of what it's doing to the n. Right now it's multiplying the n, so I do the opposite, which is division. I'm going to divide both sides by 35. And I end up getting negative 1. Once you have the n by itself, you're all done. Okay? So there you have it. If you want to see another one like that, go do number 1. Check your answer using the answer key when you're done. Let's go ahead and jump up to number 4. I'll do another one of these examples here. So like we said in the last problem, distribution is first. Now I'm going to do a different step now that wasn't on the last problem. On the last problem, we didn't have this, but we do now. I've got some like terms that I can combine together there, so I'm going to go ahead and do that. After that, the steps will match pretty good, though. So now I want to add or subtract the smaller variable. In this case, the smaller variable is the negative 2p. So I do the opposite of the negative 2, which is a positive 2p on both sides. So that goes away, leaving 12 on the right side, 8p here, and 28 here. The next step is to either add or subtract the constant on the side with the variable. This is my constant. So to get rid of that, I'm going to subtract it on both sides. That's going to be a negative number. Let me see. That's going to be 16, I believe. Negative 16. And then the last step is to divide or multiply the multiple there. The multiple there is the 8. So since it's multiplying the p, the opposite is to divide. So I'm going to divide both sides by 8, and I get -2. So there's my final answer for that one. All right, number 6, the rest of this study guide is reviewing the stuff that we learned in Unit 4, which is polynomial stuff, so just keeping that fresh in your minds. In this problem, I've got 3 trinomials that are being either subtracted or added. So for the subtraction, we're going to distribute that minus sign into the polynomial that comes after it. You don't have to worry about doing that with the one with the plus, but distributing that negative will cause all the signs in that polynomial to change. But the rest of them will stay the same. After you do distribution, if it's required, you don't need parentheses anymore, and all you need to do is combine your like terms. So like terms are 2 terms that have the same variable and exponent. So we have an n squared here, another n squared here, and that's it. So we could put those together. You can imagine there being a 1 in front of that. So what is 1 take away 7? That would be -6, and then you keep the n squared the same. I'll cross those off to show that I'm done, and I'll continue. This is a constant, meaning it has no variable, so we can combine that with other constants like the 8 and the 3. So 1 plus 8 plus 3 is 12. Cross it off to show that we're done, and we'll move on to the next one here. Next we've got n to the 4th. So we're looking for other terms that have an n to the 4th. I see one over here. And once again, if there's no number in front of the variable, we can imagine there being a 1 there. So 1 plus 8 is 9 n to the 4th. And then finally we have a 6n cubed. We'll combine that with the other n cubed. 6 plus 4 is 10 n cubed. Finally, you might want to put these things in order. You start with the term that has the biggest power, which is 4, and just work your way down. So the next one is the cube, the n to the 3rd power. The next one is the n to the 2nd power, and then finally the one that doesn't have one at all. And so that would be our final answer for that. So that's just adding and subtracting polynomials. We'll be reviewing that as well. For this next one, we're going to be multiplying. We have a binomial and a trinomial. Notice how there's nothing in between those parentheses. That means we're multiplying them instead of adding or subtracting. So when you multiply polynomials, we're going to use the box method. Since I have a trinomial, we're going to need our box to be 3 spaces long. And since I have a binomial, it'll need to be 2 high. So we'll have a 3 by 2 box. So we'll put the binomial on the side here, and we'll put the trinomial along the top. And what we're going to do is we're going to multiply to fill in our box. Now when you multiply 2 terms, like to fill in this box, I will need to multiply these 2 together. When you multiply 2 terms, you multiply their coefficients. Those are the numbers in front of the variables. 7 times 2 is 14. And you add their exponents. So this is an r to the 1st power, and this is an r squared. So 1 plus 2 is 3, so this is going to be r cubed. So the final result of multiplying those is 14r cubed. We'll continue that process. 7r times -r will give me this box, which is -7r squared. 7r times 7 is 49r. -6 times 2r squared is -12r squared. -6 times -r is a +6r. -6 times 7 is -42. And then after that, we're going to start taking our terms out in order from biggest to smallest. So we have the 14r cubed is the one that has the biggest power, so that's going to be first. Next we have the squares, and there's 2 of them diagonal from each other. We'll add those together. So what's -12 added to a negative 7. Well, that's going to be negative 19, and the r squared stays the same. Kill that. Notice I'm adding now instead of multiplying, so the rules are a little bit different. You don't change the exponents. Next, we have the r's. We're going to add those together as well. 6 and 49. That makes 55, and it's going to be 55r because they have an r there. And then finally, we have the minus 42. And so there is our final result for multiplying those two polynomials. Number 10 says, let's use this shortcut. Now, you could use the box if you want to. Shortcuts are nice, though. 2p plus 3 squared means that we have 2p plus 3 times 2p plus 3. Now, once again, you could do a box on this if you wanted to, but I'm going to use the shortcut. The shortcut is as follows. Anytime you have two binomials that are exactly the same, you multiply the two first numbers together. You multiply the two last numbers together. You multiply the two middle numbers together, and you double it. So, here we go. 2p times 2p is 4p squared. 3 times 3 is 9. We're going to multiply those together, 6p, and we're going to double it. And that's going to give me 12p. We're going to use a shortcut on this one also, but this is a different shortcut because you'll notice they're not exactly the same. So when you have this situation where they're the same but one's a plus and one's a minus, a little bit easier actually. Just do the first two multiplied together and the last two multiplied together, and you're done. So the first two multiplied together and the last two multiplied together gives me my final answer. All right, so now we're going to move on to factoring. Just to review with you guys how to factor. You always start by taking out a GCF. Now, there won't always be a GCF, but if there is, you're going to take out the GCF. Next, if there's two terms, perhaps it's a difference of squares. It may be, it may not be. But for instance, if you have two numbers that are perfect squares being subtracted from each other, then that's going to factor into a plus b times a minus b. Okay? Now, if there are three terms or four, we're going to use the box method. Okay? And that's pretty much it. So let's begin here. So the first thing I'm going to do is I'm going to look for a GCF. Is there anything I can divide out of here? Well, first of all, this one has m squared, and this one doesn't have any m's. So I can't take any m's out. But looking at the coefficients, I can divide something out of 16, and I can also divide something out of 100. I think they can both be divided by 4, if I'm not mistaken. So I'm going to take a 4 out. So what's 16 divided by 4? Well, that would be 4. And what's 100 divided by 4? Well, that would be 25. So I took care of my GCF. Now, how many terms are in here? I see 2 terms, which means maybe it's a difference of squares. It doesn't have to be, but it might be. Is this a difference of squares? Well, that's a perfect square, and so is this. So yes, it is a difference of square because they're being subtracted. So what multiplies by itself to make 25? Well, that would be 5 and 5. What multiplies by itself to make 4m squared? Well, that would be 2m and 2m. One's going to be a plus and one's going to be a minus. And at that point, we're done. All right, let's take a look at the next one here. Matter of fact, let me bring back my chart here because I think I'll use that again probably. All right, so once again, let's start by looking for our GCF. Now, the 6 doesn't have any k's in it, so I can't take any k's out. But is there anything that can divide into 12, 27, and 6? There is. it would be a 3. So if you divide a 3 out of those numbers, 12 divided by 3 would be 4. 27 divided by 3 would be 9. And 6 divided by 3 would be 2. So I took out my GCF. Now since there's 3 terms, I'm going to go with the box method. After I do the box method, we're still going to have our GCF, and the trinomial will be split up into 2 binomials. So how do we do the box method again? The first term goes in the top left box. The last term goes in the bottom right box. And now we look for 2 numbers that multiply together to make the first square. What multiplied together makes 4k squared? Well, let's try 2k times 2k. It could also be 4k and 1k. We're not sure yet. But let's go ahead and try 2k and 2k. Next, we want to get 2. What multiplies together to make 2? Well, that would be 2 and 1. Now, we go ahead and fill in our box to see if this works. 2k times 2 is 4k. 1 times 2 is 2k. We know that this works if these 2 numbers can either add or subtract to make 9, and they don't. So that means we're not right. Now, the first thing that you do when your first guess is wrong is you would switch some numbers around first. So I would try switching the 1 and the 2 like this. Now I'm going to save myself the trouble. I already know it's going to come out the same, but that is what you would typically do first, is switch the numbers. Now since that doesn't work, that means that I need to try different numbers. Apparently the numbers I've picked don't work. Now there's only one way to get 2. That's 1 times 2. So I can't change these. But let's go back to the 4k. Another way to get 4k would be by doing 4k and 1k. Let's see if that works. 1k times 1 is k, or 1k I guess we could say. 2k times 4, 2 times 4k is 8k. Do these add up to make 9? They do. So we've got our answer now, 4k plus 1, and then k plus 2. And that's the end of it. All right, one more factoring problem. So notice this time they both have a k. So I can see that in my process of taking out my GCF, I can take a k out. Also, I can take out something out of 12 and 60. I think both of those can be divided by 12 if I'm not mistaken. I think 12 goes into 65 times if I'm not mistaken. Yeah. So we could take 12 out. So if I divide 12 by 12, I'm left with 1. If I divide 60 by 12, I'm left with 5. And if I take 1k out, since this one had 2 k's to begin with, if I take 1 away, it's just going to have 1k. And since this one only had 1 anyway, if I take its k out, then it won't have any more. And so there's my answer. Now, next we would say, okay, there's 2 terms. Maybe it's a difference of squares. Well, it is a difference, but they're not squares. We can't take the square root of that or the square root of that. There's not a number that you can multiply by itself to get those. And so we're done. It wasn't a difference of squares, so we can't go any further with that one. It was just a GCF problem. All right, last problem. This is an equation. Now, I'm going to give you guys some steps for this. The first thing you want to do is move everything to one side. So I'm going to subtract this 7 on both sides, making sure you line it up with like terms as you do so. I'm also going to move this 3 in off of this side, lining it up with its like term. So now on the right side we'll have 0 because there's nothing left over there. On the left side we'll bring down the n squared We'll combine these and get 9n. We will combine these and get 18. The next step is to factor. So in factoring this, I look for a GCF. I don't see one. They do not all have an n, and since this front coefficient is only 1, we can't divide anything out either, so there's no GCF. But it does have 3 terms, so I'm going to do my box method over here. Making sure that the diagonals add up to make the middle, which is 9, and they do, so we're good. So it factors into n plus 6 and n plus 3. The next step is to set each factor to 0. And solve. And at that point, we should be done. So we do n plus 6 equals 0, and n plus 3 equals 0. And so n equals negative 6, and n equals negative 3. That last step is called the zero product property. If this times this equals 0, that means that one of these has to equal 0, so we set them both equal to 0 and solve. And so we end up with our 2 answers there, n equals negative 6 and n equals negative 3. So step 1, move everything to one side. Step 2, factor. Step 3, set each factor equal to 0 and solve. That's known as the zero product property. You don't need to know the vocabulary, but I'm just reminding you from when we talked about it. All right. And I believe that does it for today, so hopefully that was helpful. And we'll see you guys in class.